In lesson 3 of our Systems of Inequalities unit, we're going to be looking at a couple different inequalities. We need to graph both, kind of like our systems of equations, except for you'll see there's a little bit of difference here at the end when we're graphing it. So if you think of systems of equations, we're looking for that one intersection point for the solution where the two lines cross right there. There's just one intersection point. For systems of inequalities, you got to think of your inequality and that you might have this whole side shaded and then this whole side shaded. And so what we're looking for is the overlap, like this whole area here. Okay, so we're kind of looking at a bigger area. So this first equation, y is greater than or equal to negative 1/2 x plus 2. We know that the y-intercept is at positive 2. And we're going to go negative 1/2 slope, so we'll go down 1 to the right 2. Down 1 to the right 2. And that's going to be a filled-in line because we are including it with the equal sign. Alright, so that's our first equation. The second one is x is less than or equal to 2. So we're going to have a filled-in line at x equals 2. That's straight up and down because we have an undefined slope with that one. Okay, and now we're going to take a look at where we're going to shade this. So if we look at the first equation, it says y is greater than. So I'm going to shade the top part, like this part up here. And then in the next equation it says x is less than, so that means I'm going to shade this part. So the only part that I'm actually going to shade is above this line and to the left of that line. So it's got to be in this region right here, if that kind of makes sense. So it has to satisfy both equations. And then since both lines are filled in, we can go all the way to this line and all the way to this line and then any of the room in between. Again, because it's to the left or less than 2. And it's it's above this equation. So this equation goes all the way here, but we have to be to the left of this line. So it's kind of like a wall or a barrier, and it's everything in here. So let's go ahead and move on to the next example here. Again, both of these are in slope-intercept form already, so we just need to go ahead and graph it. So we have a intercept of positive 2. Slope of 3, so we'll go 1, 2, 3 over 1, and if we want to go down 1, 2, 3 left 1, it'll be right there. We're going to have a dotted line for this one because it's just less than, so like that. Okay, and we know that we're going to eventually shade this side, but I'm going to wait until I have my other line in there. Now with this one we have a intercept of negative 3 and a slope of negative 2. So I'm actually going to go up to 1, 2, left 1. So this is actually going to be a shared point right there at negative 1, negative 1. So I'm going to go up 2 again, 1, 2, left 1. So we're going to go right there, and then 1, 2, left 1. Now this is going to be a filled-in line because it is equal to. Okay, so let's get that line in there. Now the first equation, again, we are going to be to the left side of that. This is the first equation line right here. We're going to be to the left side, so all this over here. And then the second equation is this line right here, and we need to be to the left side of that as well. So we're basically this triangle kind of thing here. So let's go ahead and fill that in with our shaded region. Okay, so hopefully that makes sense. You have to be able to satisfy both inequalities. So we have to be everything down here and everything to the left of here. All right. So let's move on to our next example. Okay, now as you can see here, we're going to have to actually solve these inequalities to get them in slope-intercept form. So let me copy this over. It's going to be 2x minus y is less than negative 1, so let's subtract that 2x from both sides. Okay, so we get negative y is less than negative 2x minus 1, and then let's divide everything by negative 1. So we get, and then we're going to have to circle that inequality, so y is greater than 2x plus 1. All right, so that's our first one. Before I get too far here, I'm going to go ahead and solve for that second equation here. So I'm going to kind of divide it out. Oops. See if I can erase that. All right. So we got 2x plus y is greater than negative 3. And go ahead and subtract your 2x on both sides. And we're going to get y is greater than negative 2x minus 3. Okay? So that's our second equation. So we have this one here and this one right here. So we have the intercept. The intercept here for this first one is 1. Positive 1 with a slope of 2. So let's go up 2 over 1. Up 2 over 1. Well, let's go ahead and make the line a little bit longer this time. Down 2 over 1. And down 2 more over 1. Alright, now we're going to have that to be a dotted line because it's less than. And the other equation, we have an intercept of negative 3. And again, a slope of negative 2 here. The first one was positive 2. This one's going to be negative 2. So let's go up 2, left 1. So we're going to have a shared point right there. And then up 2 more, left 1. Up 2 more, left 1. Okay? And then this line is also going to be dotted because it's just greater than. Alright, so now the second equation was greater than. So we've got to be to this side of that line. And the first equation is also greater than, so we want to be to this side, the greater than side. So this side and this side, so that leaves us just kind of with this triangle up here. So let's go ahead and shade that in. Okay, now obviously you can see that these are both dotted lines, so anything on the line would not work, but everything here in between those two lines would be a solution to satisfy this inequality. Okay, so hopefully that kind of makes sense there. And we'll go ahead to our last one. So we need to go ahead and solve for both of these inequalities as well. So let's copy them over. X plus 2y is greater than 2. Subtract your x. So we have 2y is greater than negative x plus 2. Now divide by your 2. And we get y is greater than negative 1/2 x plus 1. Okay, the coefficient here to x, the coefficient is 1. So when you divide, I just went ahead and made it negative 1/2 x plus 1. Alright, now let's do the other equation. So we'll go x minus 2y is less than or equal to negative 6. Since I have a negative coefficient to y, I know I'm going to have to flip the sign eventually here, so just keep that in mind. So let's subtract x on both sides. We get negative 2y is less than or equal to negative x minus 6. Now we need to, let's move this up here just a little bit. So let's go ahead and divide by our negative 2. I'm going to circle that inequality. Divide by negative 2. So I'm going to end up with y is greater than or equal to 1/2, positive 1/2 x, because the negatives cancel, plus 3. Okay, so this is going to be one of my equations, and this was my other one up here. Alright, so let's go ahead and get those both graphed. So the first equation, intercept at positive 1. Okay, and then we're going with a negative 1/2 x. We got to make sure this is going down. So I'm going to go up 1, left 2. I'm going to do that again. And then I'm going to go back to my intercept and go down 1, right 2. I'm going to do that again so I can get a nice longer graph there. And I'm going to go with a dotted line. Alright, and will eventually need to be greater than. So up here, okay, it's good to think about that as you're going. And the next one is a slope of, or an intercept, excuse me, of 3. All right, with a slope of 1/2 x. So let's go up 1, right 2, and I'm going to go up 1, right 2 again. And then we'll go the other way, down 1, left 2. This will be a shared point. Down 1, left 2. Okay, and we're going to make this a solid line because it is included, okay, here with this equal, greater than or equal. Now, since it is greater, we're going to go up on top. All right, so this, they're both greater. So this one is over here, and this one is up here. So we're going to use kind of this triangle up on the top. That's, and actually, it's not really a triangle because it just keeps going forever, of course. But we're only going to do this graph portion, so it kind of looks like a triangle there. Now, it can go all the way to this line right here, but it cannot include this dotted line over here. But it can go right up to it. So just to kind of keep that in mind of what all that means. So there are your 4 examples for today's lesson, systems of inequalities.